All right, first of all, big math word called complex numbers. All complex numbers means is that you have two parts to your number. You have a real number part, separating them with a plus or minus, and you have an imaginary number part. So we've got something that's got real and imaginary pieces to it, which is why it's called complex. Now, building our way to complex numbers and where those show up, we've already seen a lot of this, so again, kind of a quick review. When you are taking the square root of a negative, that's when those imaginaries start showing up. We would simplify our radical like normal, finding our biggest perfect square that goes into 8. I always put the negative with the biggest perfect square because it is also going to come out of the radical. Square root the number like normal. Square root of 4 is 2. The square root of that negative, remember, is where we get the letter I, and our not perfect stays inside. Then we progress up to having real and imaginary numbers in the same sentence. So again, if I were to simplify the square root of negative 12, 4 again is the biggest perfect square that goes into that. But we don't lose what's out front. So it's going to be 2 plus or minus, and then I simplify here. Square root of 4 is 2. Square root of negative is I. And this is where we start seeing complex numbers. Real number, separated with a plus or minus. Imaginary number, okay? A couple notes that I will make on that is that can I combine those? No, they are not like terms. This would be like a 2x, either the I or the square root of 3. Both would stop you from combining with the 2 out front, because remember with radicals, you have to have the exact same radical to put them together if we're adding or subtracting. And an I is kind of like a variable in the whole combining like terms as well. The other thing I want to point out is the way I have it written compared to how you'll see like a math book write it, is that they'll always put the I after, and I'll tell you this is why I don't put the I after it, is because of bad handwriting. And it can be a little bit tricky. Is my I inside or outside of that radical? Exactly. It's outside, but it looks like it's in. Happens all the time. So to avoid that confusion, you will always see me write mine in front of the radical because there's no confusion then, right? Your book will always write it after because of common notation. I just don't want you to get confused. When you see it after in your book, it really is outside of the radical, okay? And then we get to this, and this should look familiar. We've done this before. Doesn't that look like the last-ish step of your quadratic formula, just maybe not simplified yet? And that's exactly what it is. That's exactly where we're building to, is that we're going to take, and we haven't gotten to this step yet, but take that answer that we've gotten from a quadratic formula that does involve an imaginary number and rewrite it in the complex format. So we will break it into two pieces. Real number, separated, imaginary number, okay? So how do we do that? Well, simplify like we are used to simplifying. So simplifying my square root of 18. Biggest perfect square that goes into 18 is that 9. Okay, and so square root of 9 is 3. Square root of negative is I. And this is how we break it then into a complex number. When we have an I, we're going to break at our plus or minus. And we're going to give both of those numbers, we're basically pulling that fraction back apart, give both of those numbers the common denominator of 6. And then, if either of those fractions simplify, you would simplify them like we are used to. So like 3 over 6 would simplify to 1/2. 3 over 6 over here would also simplify to 1/2. Okay, and again, I just kind of want to show you common ways that that can be written. If you write it in this format, beautiful. That is separated, that matches the complex format, a plus bi, where you have your real number, separated, imaginary number. Okay, commonly you will see this I slid off to the side of the fraction. And instead of writing it like this, it would be like the square root of 2 over 2i. And you can always do that with a variable, is take it from the numerator and slide it to the side. It's the same thing. And I don't care which format you write that in. It's the same answer to me. So, questions? I just don't want you to get confused. Those are the same thing. Absolutely. Yep. I just want to get us to understand the breaking from the real and imaginary to match when the directions ask us to. When they ask us to write it in that complex format, that's when we need to be able to break it into real and imaginary, okay? Now we're going to kind of buzz through these first two examples where it's adding and subtracting complex numbers. Guys, when it's adding and subtracting complex numbers, you would add and subtract it just like you would if they were x's. We combine like terms. If it has an I, it would be a like term to something else that has an I. If it's a plain number, it's a like term to something else that has a plain number. So our real numbers are 2 and 5. Put those together, we get 7. Our imaginary numbers, 3i and negative 2i. Well, 3 minus 2 is 1i. Combine your like terms, okay? The only thing you have to be careful of when we are adding and subtracting is when it is the subtracting part. Sometimes we forget to distribute that negative through, so make sure you distribute that negative to all terms following the subtraction. Negative, negative is a positive. And then I find my like terms, so the real numbers would be 3 plus 5. My imaginary number is negative 2i, negative 4i would be a negative 6i. Yes. Like in one page. Yes, it is. You guys are like killing it. Yeah, so adding and subtracting, no different. It's when we start multiplying that it gets different, okay? So where is this headed? Well, if I were to take this equation, which we know that I represents the square root of negative 1, yes? That all looks familiar? If I were to take both sides of that equation and square it, I squared is going to equal, squaring and square rooting are opposites of each other, right? Negative 1. This is what you have to look for in your equations when we start multiplying and dividing. When we see an I squared show up in our problem, we will do substitution. We will replace that I squared with negative 1. And that's what's going to change heading forward when we start doing multiplication and division. Then we would just treat a normal like x or y. Okay, so let's try to FOIL these that have these two complex numbers. The process to foiling does not change, and I'm going to show a lot of notes on this first one. Follow our normal steps for foiling. First times first, outsides, insides, and less. Also remind you that as we are cleaning this up, that we can multiply numbers together even if they aren't like terms, just like I could multiply 3 times 4x. I can multiply 3 times 4i and get negative 12i. And that if I were to take like an x times an x, I would get x squared. Well, I times I gives me I squared. And that's, as we do multiplication, the term we have to look for. I squared is the same thing as negative 1, so we do substitution. Is that instead of writing I squared, I replace it with negative 1, which will always just change the sign on my number, right? When I multiply something by negative 1, it's going to change the sign on our number. So then we'd be looking at plus 20 there. And then it asks me always to write these in our complex format, a plus bi. So real number plus imaginary number. Our real numbers are 6 and 20. Combine those to get 26. Our imaginary numbers are negative 12 plus 10 or negative 2i. Questions? We're going to look at one more that is very similar to this. However, your answer is going to be slightly different, and we're going to figure out why and how we can use that in the next step. So I'm going to let you guys do the FOIL process on this one. Expect a slightly different looking answer, and then see if you can figure out what it is about the original problem that did that to us. Did I just hear like 4 different answers to the symbol? Uh-oh. All right. Sounds like we might need to check our answers here. Yes. Can you like bring that back up here in about a minute and a half? Yes. I'll tell you what he said in just a second here. Okay, heading forward with this one, obviously we need to make sure that our arithmetic skills are doing okay, because it sounds like we're getting a couple different answers here. Again, we see that I squared happening, and when I see an I squared happening, I replace it with a -1, which is always going to change the sign on my number, right? Just so we don't forget what that was, that came from our I squared. Now, -20i plus 20i, gone. And then we have 25 plus 16, which my good arithmetic skills is going to tell me is 41, right? So, slightly different looking answer, right? We are missing an I. What is it about this problem that made that happen? Plus 4i, minus 4i. The fact that they are the same terms, different signs, right? Yep. Difference of 2 squares. You remember that phrase, difference of 2 squares? It's like a factored difference of 2 squares. Why do I need to look at this? Well, we are going to use it to help us fix this. And what do I mean by fix? And ignore and not fix my mistyped word at the top, conjugate. Conjugate. That is the fancy math word for this, but we are going to create a difference of 2 squares, because when I multiply using a difference of 2 squares, we have no imaginaries left. Why do I care about not having an imaginary left? If we look at the bottom of that fraction, and I rewrite I as what it is representing, I see that it's a radical, and you remember that rule that says we can't have a radical left in the bottom of our fraction. And we used to use this fancy math word called rationalize, but that doesn't quite fix this issue because it's a binomial. So we have to go a little bit further and create this difference of 2 squares so that our number at the end does not have an I left. Okay, so that's why we looked at this one. So that's where you go with this one, is I don't want an I left here. I multiply by that exact same thing, change the sign, because that's how we're going to get rid of that I. I also can't change my fraction, so I can't just multiply the bottom. I have to multiply it by 1, which means the same thing over itself. So I would multiply by 3 plus 4i in the top as well. Now the top is just foiling. It's going to still, most likely, have i's left in it. So we just have to follow our FOIL process up there. 2 times 3 is 6. 2 times 4i would be 8i. 3i times 3 would be 9i. And then 3i times 4i would be 12i squared. You can FOIL in the bottom. Great. We'll talk about how to speed it up here in just a second. 3 times 3 is 9, plus 12i minus 12i minus 16i squared. But I'm going to start seeing that I was about to write I squared, and instead of writing I squared, I'm going to replace it with -1. Right?
I squared and negative I squared are both -1.
All I squareds are -1. Yep. All I squareds are -1. So combining my like terms in the top, my real numbers are 6 minus 12, or -6. 8 plus 9 is 17i. Okay. And then, just as we needed to, my middle terms drop out there. 12i minus 12i is gone. 9 plus 16 is 25. Okay. And we are always supposed to write this in our complex format, which means, again, break at that plus sign, give both of them the common denominator, simplify those fractions if able. The I can go in the numerator or next to it. It does not matter. That's the same answer. So if you put 17i over 25, beautiful. Or 17 over 25i, same thing. Okay. Do check that these, if those simplify, you would simplify them. They do not. Now, let's speed up our process, if you want to. I can always just FOIL this, use this line, and get to here. okay? But the other thing I can see is that it's always going to come from this. We're going to get the first number squared, and because of the I squared, we're always going to get the second number added to it, right? It'll always end up being a positive. Usually in a difference of two squares, it would say minus the second thing squared, but that second thing squared includes a -1 or an I squared, right? So it'll always be the first thing squared plus the second thing squared to get that number underneath. And if that shortcut does not mesh with you, FOIL, okay? Any questions on that? All right, now let's talk about being lazy. That's some of our sweet spots, right? How can I be the most lazy on this problem? Now, as we look at this, I do have a lot of people that will look at that and say that I can multiply by -4i to fix the bottom. Okay, kind of sticks with our whole idea of conjugate. I don't want to do that much work. Does anyone see something that I can do that's even less than that? Just I. Can I multiply by just I? Okay, because wouldn't that make this I squared? Now again, I can't do just the bottom, so I would have to multiply top and bottom by I. But won't that fix the issue of an I in the bottom of my fraction, making it I squared or -1? Again, every time I run into an I squared, we won't write I squared, we will write -1. All right, I squared, we're going to write -1, making this -2 plus 5i over -4. Always writing things in our complex format, so -2 over -4 plus 5i over -4, which would be 1/2 minus 5/4 I. Again, the I can stay in the top of that fraction. That's totally fine. Questions? Now, would I get the same answer if I had multiplied by -4i? Absolutely. I would just have a lot more bigger numbers to work with and more simplifying to do at the bottom. So just in case anyone's trying to be extra lazy on the ones we did before that, would that have fixed the issue over here? Could I have just multiplied by I to get rid of the I there? No, because when I distributed, I would have now had an I here, and we would still have the same issue. So that's why we have to use the conjugate if it's a binomial. But if it's one thing, a monomial, we can just multiply by I, okay? All right, the last one again is the review. We have already seen problems like this where we have gotten to a factor, we've set it equal to 0, we've tried to solve, and we ran into square rooting a negative. Eventually, tomorrow, we start writing those on our answers for zeros. So, just a reminder, don't throw out the answer, is all I'm saying. Solve like normal. A couple other reminders is that when I insert a square root into a problem to solve it, I also have to insert into that problem a plus or minus every time we put the square root in there. I square root numbers like normal, so the square root of 16 is 4, and the square root of a negative comes out as an I. That is two answers, positive 4i and negative 4i. I do want to do one that has a fraction because sometimes fractions make people freeze for a second, but guys, no different, right? So if I am solving and I run into a fraction, we still can get an answer that's imaginary. Two over 8 would simplify down to 1 over 4. Square root like normal. When I insert that square root into the problem, I'm going to put a plus or minus on my answer. That when I square root a fraction, remember it is like square rooting the top, square rooting the bottom. Both of those numbers are perfect squares. The square root of 1 is 1. The square root of 4 is 2. And the square root of a negative is I. And again, that you can write that as 1/2 I or I over 2. Same answer. Okay, and again, we've got two answers, positive 1/2 I and negative 1/2 I. Now, the last thing that I have on here is because you are going to see something like asking you to do I to the 24th or I to the 35th, and I don't want you to sit there and multiply and multiply and multiply and multiply 35 times. So what I want to show you is there really is a pattern to the whole I raised to the whatever thing, and I think actually it'll be better if I just show it, writing it out here. We know that I is equal to the square root of negative 1. Agreed? Which is just I. Okay? That would be I to the first. I squared would be if I had taken this and multiplied by I, again on both sides. Or multiplied by the square root of negative 1 on both sides. I squared is negative 1, right? And if I keep going, I to the third would be if I had multiplied both sides of this again by I. That's how I get from square to 3, right? Well, I times negative 1 is negative I. So I to the third would be the same thing as negative I. Multiply both sides by I again, we get I to the fourth. I times I is negative 1 times the negative that's already there, we get positive 1. Multiply both sides by I again, I get I to the fifth. 1 times I is I, and we start over. This was, instead of me writing it as that, was I, right? And we start the process over. And so what happens is it's basically like a 4 exponent pattern. I to the first is I squared is negative 1. We already knew that. But if I do I to the third, I get negative I, and I to the fourth, I get positive 1. Okay, and then we start the process over. So basically what I want you to do is figure out in relationship to I to the fourth where that number falls in the pattern. So what I wanted you to think of is multiples of 4. If it's not a multiple of 4, then you would think in relative to that multiple of 4 what it is. What do I mean by that? Look at the exponent. Is 24 a multiple of 4? Yes. Then actually that is your answer. It will match that part of the pattern. And then if it's not, 35 is not a multiple of 4. We look at where does it fall in that pattern. So yeah, so 30, think of multiples of 4. 32 and 36 are multiples of 4, right? So if I were to kind of fill those in around here, 36 would be a multiple of 4. That would be right here. 35 would have been the one right before it. Negative I, okay? Or if you work your way back to 32, you could have worked up to 35 here, okay? I know we don't spend a lot of time doing that, but I just also didn't want you to sit there and multiply I out 35 times. Homework, yeah. Like a bonus question, maybe? Would be a good bonus question. It should. Yeah, you got that one. Yeah. Other questions? All right. Your assignment is out of the book. Now, this was a 0 chapter section, so make sure you go to the correct page. It is P8. Doing those random numbers up there.